Welcome to my session. So today I'm going to talk about my two functions, including append and remove. So first, let's look at my append function. It passes integer value and then remove its corresponding node. First, we will add our list size because we want to keep an integer value to store the size of our list. So every time we call our append function, our list size will increase by 1. After increasing the list size, we consider this if statement. First, we will make sure if the root in our linked list is a null pointer. If it is, we just add our new node to our root. So this is just simply as root is equal to the new root, and this one is a constructor in my node struct. It just passes an integer value and uh, another default pointer in the node. The next is set to be a null pointer in default. Then we can return our root. If the root is not a null pointer, that means we want to add our uh, integer value to our last node. So in this case, we will declare a temporal pointer and initialize it by root. So we iterate this temp pointer until it reaches the end of our linked list. So in this case, we just simply assign our new node to our temp pointer to the next. Then we return this pointer to our new node, and we finish this append function. Now let's see our remove function. First, likewise, we will decrease our list size because we remove one node in our linked list. Okay, so first we fetch this integer value, and it will provide the pointer pointing to the node we want to drop. Then we make an if statement. If the drop PTR is equal to a null PTR, which means that the value we want to drop does not exist. In this case, just simply return a null pointer, then we finish it. If it's not, else if it is kind of is equal to root, our first pointer, then we just assign the root to the next, which means the pointer to the next node is equal to the root. Then we finish this assignment and we isolate our prior node pointed by root. So after that, we can return the PTR we want to drop, and we finish this function. So if the dropped PTR is not equal to root, means that meaning that the PTR the pointer to the node we want to drop is not at the first, is in the middle, or is at the end. In this case, we will use an auxiliary pointer. We define it as pre-PTR, which is a pointer ahead of the drop pointer. Also, we initialize it with our root pointer, and we iterate this pre-PTR until is the pre-PTR to the next to the value is equal to the value we want to drop. This means this is actually the drop PTR to the value, but only with this pre-PTR we can manipulate uh, some some pointer we want to drop. Um, okay, so once we have this pre-PTR, we can make sure if it's uh, at the end of our linked list or it's just in the middle of our linked list. If it's at the end, which means the drop PTR to the next is a null pointer, then we consider to assign the null pointer to the pre-PTR next. Then the prior last node will be isolated uh, from our prior linked list. And if it's in the middle of linked list, we assign the pre-PTR to the next, to our pre-PTR to the next. And then the node, the prior node in the middle of these two nodes will also be isolated. Finally, since we are responsible to return the dropped node so that we can delete it, we return this dropped PTR. So that's my remove function and my append function. Thank you.